Today we are solving the problem Indivisible Permutation, which is from Starters 19. It is a simple problem. Let us see the problem statement. The problem statement here says that you're given an integer n and you have to construct an array of size n. And this array is going to contain the first 10 natural numbers. What it means is that if n is equals to 3, then the array that you are going to form will be of size 3, first thing. The second thing would be that the array will contain the first 10 natural numbers. The first 10 natural number means that 1, 2 and 3 in this case, if your n is going to be 3. Now, in what format do you have to form this array? So it is given that first of all, each number should occur exactly once in this array that we are going to form. So of course, if the size is n and we are taking the first 10 natural numbers, then it is only possible if we have exactly once all the elements. Then the condition is that P is said to be indivisible. That means your array that you will be forming, it is said to be indivisible if I does not divide Pi for every index where I is greater than equal to 2 and less than equal to n. What it means? Now, if you know about an array, then you would be knowing, right, that every array has indexes. It is recognized by indices, right? So here what we are saying, suppose like this is the first, second and third index of the array. This is an array and these are the indexes. Now we are saying that this index I, which is denoted by I, should not divide the element present in that index. What it means that if 3 is present at the third index, then this particular element P3, this is P3, right? This 3 is known as P3. This should not be divisible by I. I is here, in this case it is 3. So it should not be divisible. That is what we are saying. And for every element, this should be true for every index. So if this is true for every index, then we can say that an indivisible permutation exists. Such a kind of array is known as here indivisible permutation. And if it exists, then we have to print any one permutation of that array. And like here you can see it's given that if there are multiple such arrays, then we can print any one of them. So let us see a very simple example and then find out how we can actually form this array. So I have taken an example of n equal to 6 here, and then instead of placing the n natural numbers in their regular format like 1, 2, 3, 4, 5, 6, I have placed them randomly. And now we are just going to check for every index whether this is true or not. That is what we are checking, if Pi divided by I should not be divisible. This we have to check. This division should not be divisible, right? So here I are these values, these indexes that you see 1, 2, 3, 4, 5 and 6. And this element which is present in the indexes, this is Pi. So let's check for the first one. So now for the first one, we don't have to check, because what is given in the question, that I greater than equal to 2, less than equal to n. And this is because this 1 will always, like whatever number 1 divides, it will always be divisible, right? So how can we check for this? Let's move on to the second index. Now here we will check 4 is divisible by 2, right? 2 2s are 4. So here we have found that this array or this permutation is not divisible in the first go only, right? So this is actually divisible, like Pi is divisible by I. Now let us see for the third one. So here 6 we have placed. Again, if you divide 6 by 3, then this is again divisible. So again we are for sure saying that this array is not an indivisible permutation. Now 1 divided by 4, so this is not divisible. 2 divided by 5, this is also not divisible. 5 divided by 6, this is also not divisible, right? Now what can we observe here? we have even numbers and we have odd numbers, even indexes and odd indexes. Now what can you say about even numbers? We can say that an even number, if an index is even, that is if I is even, then it will always divide an even number. It will whatever number is even, if pi is even, then in that case we will be for sure that it will always be divisible by I. An even number will always be divisible by an even number, right? But an even number will never be divisible by an odd number. You take an example of 16, for example, and just try to divide it by any odd number, for example 7, 9 or 11. It will never be divisible, right? So what we can do, we can place all the even numbers at the odd spaces. What we are supposed to do, we will place all the even number at the odd indexes. And what we will do for the odd numbers, now when we have already seen that where we have to place the even numbers, we are left with the odd numbers. So we can simply place those odd numbers at the even indexes. If we place the odd number at the even indexes, then again the same thing, that even indexes will not be able to divide the odd number. Like 9 will never be divisible by 2, right? 9 will never be divisible by 4. 9 will never be divisible by 6. So an odd number will never be divisible by an even number. So the solution is very simple. What will be the solution? Let us see for this particular example what the solution is going to be. Let us make this is we have formed an array which is of 6 elements, and how we are going to place them is, this is the first, second, third, fourth, fifth and sixth index. So at the first index, this is an odd index, so here we are going to place 2. After 2 comes 4, so again the even ones we are going to place at the odd index. So we will place 4 at the odd index, next odd index, which is 3. Then after 4 comes 6, so we will place it at the odd index, which is next odd index 5. Now we are left with the odd numbers. So what you can do, you can place 1 at the last position, then you can place 3, and here you will place 5. So this is how you can form. You can also, what you can do, that for placing the odd numbers, you can also do like this, like 1, 3 and 5, which is absolutely fine. It is your choice. You can place any number at any place. That is not a problem, and the solution will not fail. So it is up to you that which odd number and where you want to place at which even index, and which even number you want to place at which odd index. But to maintain a certain kind of order, we are just placing it this way, that like we have placed at the first odd index, we have placed 2, and after 2 we have 4, so we have placed 4 at the next odd index. So this just maintains an order. It is easy to do it in the code. Now that we have understood the solution, let us see the input, output and constraints, which is very simple here. The first line will be the number of test cases. For example, we have 2 test cases, and the first and only line of each test case will have a single integer n. So if we have 2 test cases, then there will be 2 n integers, which let's say 4 and 5. These are the 2 n numbers for which we will have to find the indivisible permutation. And the output format will be that you have to print this indivisible permutation. So in this case, where we took n equal to 6 as an example, this will be the array that you are going to print in space separated integers this way: 2, 3, 4, 5, 6 and 1. This is how you are going to print your answer. And the constraints you can see are not very large. Here you see that n is up to 10 to the power 5. So let me tell you something, that what a mistake you can make. So this is very simple, right? This we can just do by looping it. But what mistake you can make is that for each and every element, or for each and every index, you also start checking. You increase the operation and you start checking whether pi is divisible by I or not. But this check is not needed, because we are for sure that an even number will never be divisible by an odd number and an odd number will not be divisible by an even number. We are sure. So that's why we don't have to place this check there. Now let us see the code, which will be in C++ as well as in Python. So guys, first we will see the code in C++. It's a very simple code. Here you can see that I have taken the inputs, and after taking the input, we are just running one for loop. And in the for loop, what I'm doing, that I'm running this loop from 1 to less than n. So first we will print the values for the indexes 1 up to n minus 1. And what are we going to print? For 1, we need the value to be even, right? And 1 plus 1 is 2, which is even. So that's why we are printing I plus 1 here. So whatever will be I, suppose I is 1, so it will make it 2, which will be even number in an odd index. Suppose if I is 2, then it will make it 2 plus 1 equal to 3, which means that odd number in an even index. So that's how it goes. That's how the solution will keep forming. Now at last, for the nth index, which is which will be larger, always larger than 1, right? So any number which is larger than a number cannot be divisible. So if we place 1 at the last index, then we can be for sure that it will never be divisible, right? So that's why we will place 1 at the end. You can also place it in between if you want, but then you will have to create 2 for loops for that. One for loop for placing the for forming the array which will have even indexes, and one for loop for maintaining the array which will have odd indexes, odd numbers, and then you will print that array. So you will have more space complexity, more time complexity, because you will be creating one different array and then you will be printing that array. If you want to place one somewhere in between, but this way you are decreasing your space complexity. You are just printing everything. You're not forming an array, right? You just have to print the permutation. You don't have to form anything. So that's why this is the best method to do it, and this is one of the mistakes that you can make, which can also lead to your answer not getting accepted or memory limit getting exceeded. Now we will also be seeing the code in Python. So I have not typed the code in Python. Let us remove all this. Okay, yes. So we will be typing the code in Python with you. First, I have taken the inputs. So I hope you know how to take the input in Python. This is just syntax. After that, we'll be using a for loop. So let us take a loop from 1 to n minus 1. Okay, from 1 to n, sorry, yeah. So it will go from 1 to n minus 1 if we place 1 comma n inside the range function. Now after that, what we will print? We will print I plus 1 and end equals to space. And why we are giving end equal to space? Because in Python what happens, that print function always takes whatever we are printing to the next line each time the print function is called, and placing this end there, it ensures that our answer remains on the same line, because that is what we want. And after coming out of the loop, we will print for the nth index. So let's print 1 and then again end equals to, but this time it will be slash n, right? It will be backslash n, because we want that it should go to the next line. So let us submit this code and see if we are getting the correct answer. So this submission I made for the C++ code, so we are getting the correct answer with that. But now let us check with this Python code as well. So I hope that everything is correct here. And meanwhile guys, if you understood the solution, then please do like the video. I know it is a bit long, but I wanted to explain it very nicely. So here we have got the correct answer. This is the code in Python that you can use easily for this question. Please subscribe to our channel, and that's it for this video. I'll see you in the next one.